Good afternoon. Thanks for joining XtremIO vBrownBag session here today. My name is Chhandomay Mandal. I am with Dell EMC Storage Solutions team. XtremIO is a purpose-built all-flash array that is designed from the ground up to take full advantage of the flash media. It offers consistently high performance with low latency, irrespective of the type of workload you throw at it, the number of workload, the life cycle of the workload. It also offers unique inline all-the-time data reduction capabilities, leading to very high storage efficiencies. And its modular design helps you to start really small from couple of SSDs to scale up and scale out with literally petabytes of storage in a single cluster. And finally, XtremIO is known for XtremIO virtual copies, which solves the copy data management problem in a very efficient way. It integrates with various applications with automation and orchestration capabilities that leads to application admins managing their copies, creating snapshots, creating application consistent copy, and changing their application workflows. So let's take a little bit dive into all these four aspects. As I said, the basic unit of XtremIO is called an XtremIO X brick. It comes with two controllers and a DAE. You can start with as small as 18 SSDs, and you can keep adding SSDs to the DAE for a full X brick to offer up to 230 terabyte raw storage capacity. Now, when you need to grow further, you can actually scale out linearly, both for performance and for capacity, adding more X bricks into the cluster non-disruptively, scaling up to 920 terabyte of raw capacity. Now, when you consider the data reduction efficiencies, a single XtremIO cluster can go up to nearly like 5 petabyte of effective capacity. So as you see, you can start really small, but then scale up and scale out to petabytes of storage. How do we do it? Heart of XtremIO is what we call a content-aware metadata engine. Now, we do not store data based on their logical addresses. We actually do data placements based on the content. Think of it this way. As the data come in, we chunk them into blocks. And for each block, we apply a fingerprinting generation algorithm. This algorithm acts on this block of data and creates a fingerprint. Now, the characteristics of this is, if two blocks are identical, the generated fingerprint will be exactly the same. However, if two blocks of data differ even by 1 bit, the generated fingerprint will be completely different. There is no correlation. So this random nature helps us distribute the data evenly. And let me show you how it happens with a very simple example. As you see, here are various data blocks. There are two data blocks in blue that have the same fingerprint because they are completely identical. Now, if you look at it, these are hexadecimal numbers. And we can actually devise a pretty nifty addressing scheme so that we can distribute this data evenly throughout the cluster, irrespective of how large the cluster is. So it helps us, like when we scale, no matter how large we scale, we can have an inherently balanced cluster. We can completely eliminate hotspots from this entire cluster, and we can actually offer the same full performance to every LAN that is on the array. How we can make this happen? these hexadecimal numbers, the starting values of these hexadecimal numbers are 16, right? 0 to F. Now let's imagine a scenario where we have 2 X bricks with 4 controllers. So we can distribute these 16 hex characters into groups of 4, with each controller being responsible for 4 of those starting values. Now if I go back to my original example, you can see based on the first hexadecimal digit, we can decide which controller is going to take ownership of this particular block. For example, the first one starting with 2 goes to controller 1 of X brick 2. The last one, blue block, with starting digit 9 goes to controller 2 of X brick 1 of the lower left-hand corner. So as this data come in, we apply this technique and put these data blocks in the appropriate position. And because of the inherent randomness, it gets evenly distributed, spanning the entire set of controllers, entire set of SSDs. Now look at this duplicate data block, right? We have seen this data before. So when we detect the same fingerprint, all we need to do is update the metadata without actually writing anything to the SSDs. So for us, when the data is duplicated, we actually eliminate it, committing the writes from memory, and then actually just metadata updates in memory. So everything is done in the control plane itself for duplicate data, and we can offer faster writes when writes at the memory speed when duplicate data is involved. Now, how does this relate? The other part of this is we keep all of our metadata in memory. These metadata are very granular. Now, as we scale, all the X bricks are connected through an RDMA fabric. So the entire memory is effectively a global shared pool with all controllers having access to this entire memory pool with the same speed. This helps us for every controller to participate in every LAN, in every I/O processing, and keep the cluster balanced, no matter whether you have like 1 X brick or 4 X brick, so on and so forth. And it also has some benefits in terms of this data reduction technologies. We get this data reduction technology in memory inline because it's always done in the data path, almost as a side effect of this intelligent content-based addressing scheme. Now, where does it manifest? So for example, you need to clone VMs, be it in a VDI environment or a private cloud type environment. Now, when VAAI xcopy command comes in, for us, all we need to do is update the metadata in memory, because we do not write anything to the SSD layer unless it's unique. And by definition, when you are cloning, you are copying, there is nothing unique about it. So for us, cloning actually happens at memory speed in the control plane without touching the SSDs, without touching the data plane. So the beauty of the scheme is not the SSDs, but the 100% in-memory metadata and how we are managing it. And another side benefit is the XtremIO copies. As I said, the copies, all it will involve is updating the metadata pointers in memory without consuming any extra capacity in the SSD layer. And these copies offer the same performance as the production volumes. And you can create any topology with these copies. In fact, you can actually get rid of your original volume and run workloads on these copies. So it becomes an efficient tool in the copy data management problem. So you have a database. For each database, typically there are at least like 8 to 10 copies for test dev, analytics, backup, you name it. So with XtremIO's scale out performance and the XVCs, not only we make sure you can run all these workloads, all the copies in the same platform, but also we offer orchestration and automation with applications like Oracle, SQL Server, etc., so that the application admins can actually create those copies, not only create those copies, but also they can schedule, refresh, rollback, all those things. And using the REST APIs, you can actually automate these processes to create self-service for your IT admins. Now, as far as the VMware ecosystem is concerned, we have a lot of integration points ranging from our VSI plugin that is right in the vCenter. From your familiar vCenter interface, you can do all of your storage management and monitoring operations. Here I have a screenshot of the XtremIO vRealize orchestrator plugin. Using the plugin, you can actually create your storage workflows like volume creation or like creating copies, all those things. And for XtremIO, we have actually published a lot of these best practices as well as reference architectures. As I was mentioning, that small 2-controller 18 SSDs can actually host up to 4,000 desktops. We have actually tested it in real production environment and have published reference architectures that you can refer for your deployment purposes. So to sum it up, because of its intelligent 100% in-memory content-aware metadata engine, inline all-the-time data reduction technologies, you can consolidate not only your production workload, but also your test dev, reporting, analytics, a lot of these workloads onto the same platform, meeting your SLAs and lowering your capacity footprint, simplifying your infrastructure. So with that, with the time I have left, I'll take questions, and I know you have one. So yes, so the question is, suppose you have one X brick with data evenly laid out. Now, you are adding another X brick. What happens? I keep claiming that it will be balanced, right? So what happens here? So as soon as you add another X brick to the cluster, the mechanism in terms of like which fingerprints will be belonging to which controller, that gets done, taken care of like dynamically right at that point. So all the data blocks that are coming in from that point onwards will be distributed according to the new address spacing. However, in the background, as like all the data that were in the original X brick, that will also be moved around so that when you are going from 24 SSDs to like 48 SSDs, the data will be eventually migrated over. But the key point here is, as this thing happening in the background, all of your applications will actually be able to get all the SLAs that they were seeing. There will be no impact to any of your SLAs, any of your applications. With the performance headroom that it has, it will be able to service not only the incoming IOs, but also the IOs that are necessary to rebalance the cluster once the new X brick is introduced. I'm out of town, so I'll take rest of the questions on the side as a courtesy to the next presenter. Thank you.